if you should have Fiji installed on your systems and updated. If you want to follow me with the slides and the demo what I'm doing. Also, you can follow along with the slides as we go along. You can find them at imagej.net/presentations. So the website's right here. So imagej.net/presentations with a capital P. And then we're following the living workshops that are linked up at the top. And we'll start with the introduction to Fiji. ImageJ, Fiji. Same thing. We'll talk all about that today. So hopefully today we'll get through the introduction and then also segmentation workflow. So that's the goal. But we have a lot to cover, so I'm going to be moving quickly, very quickly. But this workshop is not intended for you guys to walk away feeling like, oh, I'm a super expert at ImageJ. This is a bunch of cool stuff that ImageJ can do, and here are some tools that you can use, and exposure kind of deal, okay? So I will be going quickly. That's all. And two, we are recording this today to actually create a resource online for other people as well. So still saying that, don't be shy with asking questions. My priority is you guys here in the room. Allison is here to help as well. So if you have issues with your particular setup, like you missed a step or you just need a quick help, just raise your hand. Allison's walking around and checking to make sure everyone's doing okay. Also, if you have a question, she has a microphone. Ideally, we'd like to record your questions for the sake of this video, if that's okay. But if you don't want to be recorded, you can always just wait till the session's over at the end and ask me questions. We'll stick around a little bit at the end. Stopping the video, and then you can ask questions freely if you want. I think there's the Wi-Fi is the Discovery Guest that everyone can have access to. So these slides, also just a note that these slides are in a thing called Reveal. So if you get lost, you can just move them through them using the arrow keys or spacebar. But if you get lost, because they're actually two-dimensional, you can just hit Escape and move through the slides. See, there's like one that takes down here, so they're 2D slides. So if you ever get confused with where we are finding the right slide, just hit Escape and move through with the arrow keys. So again, the slides are at our ImageJ wiki page, so imagej.net/presentations with a capital P. If you guys just have Fiji opened on your systems, you can just follow along with what I'm clicking. But if it's too fast, then don't worry. Again, two of these slides are always available for you as a resource to go back to. So we always have them posted online. So you can always go back and use them as a resource. There's active links in all the slides. So you don't also have to stress about making notes. But does anybody have any questions before we get started? No. You all look very intent on setting up your systems, which is good. I like your faces right now. For those of you guys walking in, just grab a seat, pull up a chair, get comfy, and open Fiji on your systems as well if you want to follow along with the slides. The link there is at imagej.net/presentations with a capital P. And we'll start with the introduction to Fiji slides. And again, if you guys have questions or need help, just raise your hand. Either I can help you verbally. Allison is also in the back of the room. She's walking around to make sure everyone's doing okay. And I'd say let's get started, because it's 2 and we've got a lot to go over. Well, we'll wait for you guys to move the table. Okay, let's get started. So what is ImageJ? So ImageJ is an open source software package that's specifically built for scientific image analysis. Okay, this is not Photoshop. This is a tool for doing science, which is why presumably you're all here, right? So it's really been designed to be aggressively transparent, as this leads to open science, and not to mention the fact that we are we're federally funded by taxpayers, our work in building this system. So ImageJ is built on others' research, right? And it's extensible, and of course, science is the same. So just as you wouldn't publish in your paper, for example, I added 500 milligrams of chemical A. Like, you need to disclose what that chemical is, right? And nor should you treat image data in that same manner by using some black box of a software for your image analysis. So ImageJ is all about reproducibility, so much so there's even a command that bundles up the exact version of ImageJ you are using. So you can even publish a link in your next paper so others can actually reproduce your results exactly as you did. So again, it's about reproducibility, transparency, and I know I'm already hammering this into you, but it's really important and really important to us as on the ImageJ team. So obviously all of you have heard of Fiji, ImageJ, yes? Do you know the difference between the two? No? Some are saying no. Well, actually, Fiji stands for Fiji is just ImageJ. So it's pretty much the same. It is the same thing, except that Fiji is really just a collection of image analysis tools and plugins that was made specifically for life scientists. So it just comes with like a bundle of different tools and plugins for you to use immediately. So everything we discuss in these workshops today is in the context of this distribution of ImageJ is Fiji, right? So these are just like, for example, some of the tools and methods that you can carry out in Fiji. In general, opening, visualizing multidimensional microscopy images, registration techniques, segmentation, which we'll go over in the latter part of this workshop, image measurements, 3D volume rendering, and so on. So the ImageJ Wiki, this is our go-to place to learn, right? So for beginners as well as advanced users and developers alike. There are 3 main calls to the ImageJ action. So this is like our homepage. This is where, if you have questions or whatever, this is one of the first places you guys should search, is the ImageJ Wiki. And there's 3 calls to action, like I said. There's the download, so download the different versions. To learn, those are typically for beginners. If you're interested in different image analysis techniques, that's a great place to go in. And then for developers, so people who are interested more in building tools and scripting, a little bit more advanced techniques, technically, that's where you would go. So we've spent a lot of time and effort to make this wiki approachable, but it's not perfect, right? But it's a wiki, so you guys can actually help us make it better and edit it, which would be wonderful. So if you come across a page, something doesn't make sense, or even if you see a spelling error or something, you can actually edit this website, right? It's built by the community of users and developers of ImageJ. Okay. Also, if you're trying to search for ImageJ resources, you can use this targeted search portal. There's a link here at the bottom. It's search.imagej.net. It's a targeted portal for ImageJ. So you can search more specifically on the website, on our wiki page. You can search the code if you want to know specifically what an algorithm is doing and how it's implemented. You can search the ImageJ forum as well. So this is one of the big takeaways for today's workshop that I hope, there's 2 big takeaways, and this is number 1, is that the guys use the forum. So this forum is an amazing place that we created recently within the last year and a half, as like a place for the community to gather online to help each other, right? So obviously you want to save time, but of course, and more importantly, you want to do better science, right? So there's a whole open source community of ImageJ's users and developers as well as experts in image analysis that are all here on the forum that can help answer your questions. Even if you think it's super basic, do not worry. We get basic questions all the time. We get super advanced questions all the time. It's a whole host, a whole mix. It's really there as a resource to get you guys going with using ImageJ as well. Like, it's a great place to search for stuff. If you're getting started with segmentation, people have posted images of like, oh, these are these particular cells that I need to segment, and can give you kind of clues as to where you can start your own analysis. So yeah, this is a great place to go. So that's one of the big takeaways from today, is go to the forum, forum.imagej.net. What's also great about the forum and ImageJ in general is that we have a huge user community that really spans the globe. So what's cool is that sometimes if you're up late, you're thinking about your question, you post something on the forum, you could potentially wake up the next morning with your answer because of the time change. So many users across the globe are on there. You know, it's a really great tool. And this is what the strength in ImageJ is, that community that exists and that you have access to. And one of the ways you have great access to is via the forum. So the other big takeaway today, so those are two things that I want you guys to really, if you walk away with just remembering two things, it's the forum and now this, the command finder. The command finder are really going to save your life when you're working in ImageJ, and you'll see a lot of things are hidden in different path menus. So Control L is your friend. So we'll just switch over to Fiji now. And to activate the command finder, you either hit Control L or just L. And so now you can actually search for different commands. For example, I want to open a sample image called blobs. This is one particular sample image we will open later. And I want to do a Gaussian blur. So instead of having to, like, where was that function hidden in the menu, I can just type it in directly in the command finder and boom, I can run my commands. So it really just helps streamline your workflow. You don't have to like click and drag and search for stuff all the time. So command finder, shortcut is Control L or L, okay? So the main window of ImageJ, wow, isn't this impressive? This software is a beast, right? Okay, it's not really impressive looking, we know. It's very simple, but really there's a lot going on under the hood here. So it's really a powerful tool for you guys. So looks can be deceiving in this case, okay? So there's three main sections of the window. There's the menu bar, which contains things like the file, edit, image, process, analyze, the different plugins. And then there's also the tools. So actually tools are things for like drawing ROYs. So you have like squares, rectangles, circles, lines. So if you see some of these guys have a little red triangle at the bottom of that cube, that square, that means there's other options that are hidden inside. So if you actually right click on those, specifically, you'll see a little drop-down menu. So for the line, for example, the default is a straight line, but you can also draw a segmented line or a freehand line. And also those particular options that have those particular ROYs that have that red triangle, if you double-click them, you can also adjust in other parameters that are hidden there. So if you double-click, you can actually adjust, for example, the line width of that you're drawing. Okay, so those are just kind of like hidden little secrets in there. Then you also have the status bar. So if you actually hold the mouse over, click on the status bar, you can actually see the version of ImageJ that you're running and the version of Java that it's using. And a lot of times if you come into problems like bugs in your software or whatever, a lot of times on the forum, if you post a question, people are going to ask you what version you're running of ImageJ as well as Java. So that's just a quick and easy way for you guys to find that information and let those developers know. Okay? Yep. So also, sometimes, you know, if you're, like for example, you're opening, I'm just going to do this as an example, you're opening tons of images. Tons of images, right? And like your main window, sometimes all these windows get popped up and you can't find your main window again. All you have to do is hit enter and it'll bring it right to the front, which can be handy. Instead of spending all this time moving windows around, you can just hit enter. Okay, and the main window comes right forward. Okay, so I'm just going to close all those. Okay, staying up to date. So ImageJ2 is the newest version of ImageJ. Don't worry about this ImageJ2, ImageJ, Fiji. For your purposes, they're all the same. So ImageJ2 is just the newest version of ImageJ that Fiji is using. And one of the main features it leans on is this updater. So you'll see when you start Fiji, it'll ask you if you should update. Like normally we recommend that you do, right? Because that way you get all the newest bug fixes and changes and updates to all the different plugins that are packaged within Fiji. You can also manually go to the help window and update from there. So actually we apologize, the help window is a bit of a mess at this point and it's on our to-do list. Unfortunately, there are 3 different places where you can update ImageJ on this help menu list. So the 2 that are right here at the bottom, so this update ... as well as update Fiji, actually do the same thing. So we apologize, we will fix this. But for your purposes, these bottom 2 updates will carry out the same thing. This upper one, this update ImageJ, is specifically for the legacy version, the older version of ImageJ. So that one you don't really have to worry about, okay? Just so you're aware that those exist, that's where they are. Okay. So memory management. This is just something I want to mention because it's important to keep in mind when you're working. When opening images in ImageJ, it reads in the entire image into memory for better performance, essentially. So obviously this can be a bit of an issue if you're working with large images. So in general, it's a good idea to just kind of have that in mind, which is why I'm mentioning it here. So when you first launch ImageJ, it's going to guess how much memory it should be using, which it usually estimates about 3/4 of the RAM of your system. And most often that's good enough. But sometimes you need to tune it a bit, right? So actually this is where this memory and threads comes in. So if you search in your command finder, just type in memory, you get both of these options we're going to talk about. So first, memory and threads. So you can actually increase the maximum memory that your system is using. You can change that number and then you just have to restart ImageJ for it to actually take hold. As well, you can work in parallel threads. So some plugins will use all cores. So this is just a way where you can tune the CPUs that are used at once. But usually default is fine. But this is where it exists if you want to tune it yourselves. Also, the other option, monitor memory. This actually just does a log of the memory that's actively being used on your system. So if you're running a script, doing any batch processing, and you notice that parts of it are a bit slow, you can actually have this monitor memory running, so you can see in your script maybe where things are slowing down a bit to try and optimize its performance. 2, for example, if you click the status bar, this is just kind of an interesting thing to keep in mind. It does a little memory dump. So you'll see a little blip there in the memory. So if you actually just click the status bar, it does a memory dump of everything you don't need, just kind of trashes it and clears the memory a bit. So, okay. So step 1 would be what? Obviously opening your data, opening your images to take a look at them, start your analysis. So I'm sure you're all aware that there are literally dozens and dozens of proprietary file formats for image data, right? Like Zeiss has their own file format, I don't know what other types of images you guys are using, but each one has its own file format. So ImageJ does what it can to really open them all, in a good way. But obviously, this is a problem in general. So it does its best, like I said, ImageJ, but there are 3 main ways that you can open images. The first one is just the simple drag and drop. So you literally will just have an image here, and you can drag it onto the status bar, and it will open the image. This is the same as if you go File, Image, Open, okay? But we don't actually recommend doing the drag and drop method for your data sets, specifically for TIFFs, because sometimes the metadata, it doesn't really work in every case that the metadata is read incorrectly. So I'll do it just for simple PNGs or JPEGs or whatever, but if I'm working with my own raw image data sets, I never drag and drop my images in. Primarily I use bioformats. So have any of you heard of bioformats before? Yeah, a few of you? Okay. So basically, it's a library for opening various file formats. So it can support handling different files. So personally, like 9 out of 10 times, this is what I use. This is honestly my default option for opening images, because now you know that your metadata is being handled correctly and read in correctly. So let's go ahead and do that. So just to run bioformats, we can search in the command finder, bio-formats importer. Okay, so it's bioformats, and then start typing importer, and you should see it there. So bioformats importer, and I'm just going to open a TIFF that I have here. And this is the window that should pop up. So you've got different options for viewing your stacks, and what's great about bioformats is they have an information window that describes all the different options, kind of gives you an idea. Also, again, talking about memory management, if you have a huge image, again, you can actually open it as a virtual stack, so that's an option here. So basically, it's a read-only way of reading in your image. So if you have a huge confocal stack of images and you move to like slice 25 and you manipulate that image a bit, like you adjust brightness and contrast or whatever, and then you move to the next slice, it's going to revert to the original view. Like, so that those changes that you made aren't saved, because again, it's just a read-only view into it, but it allows you to kind of quickly see your data. You can also crop images on import if you want, if you're working with large images. So yeah, so there is a third option. I'm just going to mention it here quickly. But right now, we're not going to go into too much detail because it's not really up and running yet. But I just want you guys to know that ImageJ is actually developing our own file format reader called Scipio, and that one day it's basically like a bioformats for ImageJ. So that will actually soon be the default open images. So now we don't have to deal with this. Should I use drag and drop? Should I use bioformats? It'll just be open image. Simple. But unfortunately today, it's not so simple, but just use bioformats importer and you'll be good. Okay? Okay. So pixel types. So do you know what I mean when I say like 8-bit data? Have a general idea? Right? So, okay. So bits basically refer to the number of possible values that you can give each individual pixel, right? So each pixel is a measurement, but what we need to do is decide on a precision for that measurement. So with more precision comes more memory, takes up more space, right? So for example, the 3 different bit types here, we have an 8-bit, which is integer values ranging from 0 to 255. So that's literally just 2 to the 8 values. Pixel values you have options for. Then 16-bit is integers values ranging from 0 to 65,536, 35. So that's 2 to the 16th different values. So that's essentially what we're discussing here. 32-bit is a bit special. It's a floating point number. So that refers to actual real numbers. But in the end, you have a bit of a trade-off with range and precision. But essentially, it's a scientific notation with limited numbers after a decimal point, and it also takes into account sign, so negative values and positive values. Yeah. So that essentially are the pixel types that ImageJ can handle. So yeah, knowing the limits of your data. So we're just going to do a quick demo here. And we're going to open actually a new image. So file, new image. And we're going to create a new image that's a 32-bit type filled with a ramp and just a small guy, just a 20 by 20 pixels. Okay, so if you want to follow along, we're just going to create a new image that's 32-bit type filled with a ramp and 20 by 20 pixels. So when we open this guy, we'll get this teeny little image here. And if you hold the mouse over the center of the image, you can actually just use the plus and minus keys on your keyboard to zoom in and out. Okay? So now, once we're zoomed in a bit, you can actually probe the different pixel values. So on the status bar at the top, you'll actually see the position of my mouse as well as the pixel value. So the value is, in this case, is 0.25. So we have values ranging from 0 all the way to 1. But now what we're going to do is just do some math on these guys. So we're going to multiply, these are really small pixel values. We're going to multiply them by a really large number. In fact, we're going to multiply them by 100 million. So that's a 1 followed by 8 zeros. Okay? So if we multiply it by 100 million, okay, something weird happened to the image, right? Don't worry. It's just a display thing, because previously we were just looking at pixel values from 0 to 1. Now we're looking at pixel values, in theory, from 0 to 100 million. So this is just like a viewing thing, a display thing. So we just need to, the first thing you should think of is like, no, nothing wrong happened with my, nothing wrong happened with my data. The only thing I need to do is adjust brightness and contrast. It's just a visualization thing. So if you just type in the command finder, brightness and contrast, so we're going to adjust that by clicking auto, and we're just back. Again, we can see our ramp. It's just adjusted after we did our maths. So now if we're actually probing the pixels, we can see there's some wonky things going on in our pixel values. Do you see there's some weird results that happened? Yeah, the numbers aren't adding up, right? So because we are increasing this precision in our 32-bit float values, we're multiplying by these small numbers by really large numbers, there's an imprecision there. Like, computers are discrete. So it's just important to remember that the maths in these cases are not always perfect, which can seem scary, but don't be scared. Okay. So it's an approximation of space, essentially, right? Okay. Oops. Okay, so getting to know your data. So obviously the first thing you want to do is just look at your data. But what's the best way of looking at your data? The best way of looking at your data is looking at those pixel values, right? So let's open this example. It's called boats. So in the command finder, again, just L or Control L, we'll type in boats and open that guy. So we can see there's boats and everything, but what we want to really do to get our science out is to look at those numbers, right? So let's use the histogram. So that is this histogram, analyze histogram. So now we're talking. Now we're actually seeing all of our pixel values of all of our pixels in one go in this histogram. And we can actually probe the histogram. If we move the mouse over it, we see, for example, on the bottom right-hand side, this gray value, which is 138, I've got 4,381 pixels in my image that equal that value, okay? So two, the histogram also gives you great insight into your acquisition settings, right? Like, did you set up your scope correctly? For example, look at this histogram. There's obvious issues here. Anybody see what the problem is? Like, you have saturated pixels, right? You basically haven't filled up the entire histogram. You've got lost information here, okay? So then that would be a sign to go back and you need to acquire new data, okay? Okay. So profile plots, so that's another great way of like looking at your data sets. So let's go back into ImageJ and open that blobs example. So it's called blobs. And what we're going to do is use that straight line, Roy. So just use a straight, you could use a curvy line if you want. I'm going to use a straight. And just draw a line across any of the blobs, any number of the blobs, it doesn't really matter. And then we're going to plot the profile. Plot profile. So we're actually going to see the data across that line. The pixel values across that line. Okay? And just across that line. So again, this kind of points to really looking at the numbers in your data as the true source of information, right? So for example, do you notice anything strange between this plot and the image itself that might be a little bit backwards than What do you think? Anybody? Yeah, it's plotting gray value, because we're dealing with an 8-bit image, so we have values from 0 to 255. So if you actually look at the pixel values over the blob, the dark blob, we get pixel values that are relatively high, right? And it's only because, like, so for us, a high value is usually white, something that's white. Low values are usually dark. So actually, it's just showing us that this image is inverted. And actually, it tells us at the top of the image it's actually inverted. So it kind of cheated a little bit, but that's the thing. Like, just because the blob is dark doesn't mean the pixel values are low in any case, in this case, right? It's not until you actually probe the pixel values that you can actually see that, all right?